All right, so I did the pros and cons of 5G, and I also looked into the history of mobile networks. Okay, so first, what makes up a mobile network? So on the right, we have a picture of just a simple tree, well, not simple, but tree diagram of a mobile network. And it starts off with the mobile station, which includes the mobile equipment, and a SIM, which is a subscriber identity module. And it shows the subsystems that connect that mobile equipment to the public switch telephone network. And on the left, I just have a little bit of, I just blew up the descriptions of like the BSC and the BTS and all that stuff. So, yeah. So, the history of cellular phone networks. First, we have the first generation analog cellular. This was in the 1980s, and I have a little image of what one of the phones might have looked like. So, the first analog cellular system deployed in North America was the Advanced Mobile Phone System, or the AMPS. There were a few issues with it. It was unencrypted, it was vulnerable to eavesdropping by scanners, it was susceptible to cell phone cloning, which is copying of identity from one cellular device to another. It also required significant amounts of wireless spectrum to support. Now we're moving on to the 2G network, which is the digital cellular. And this was in the 1990s. And you can see there's quite a few different types of cell phones, flip phones, and there's a few new ones. So the 2G used digital transmission instead of analog. The 2G phone system was called IS-54 and was deployed in the same band as the previous AMPS, so it displaced some of the existing analog channels. The average distance of transmission between the phone base was shortened when the switch from 1G to 2G happened. There was an increase in battery life. More advanced batteries meant more energy efficient electronics. Also, SMS and messaging were introduced. So as these 2G phones became more popular, the demand for more data and speed increased, which leads us to the 3G network, which is mobile broadband. This was started in the 2000s, and as you can see, there's an image of the iPhone 3G. So in the mid-2000s, an evolution of the 3G technology was implemented. The 3G network used high-speed downlink packet access, which allowed for higher data transfer speeds and capacity. By the end of 2007, there were 295 million users on the 3G network worldwide. Soon, the 3G network was available to multiple computers over Wi-Fi by using a compact wireless router. The 3G network also provided in-handset internet usage, increased high-speed internet access to multimedia applications, and it also focused on data and internet transmission instead of just voice. So now we have 4G and LTE, or the native IP networks. And the timeline is from 2010 to now. Soon the 3G networks became overwhelmed by the need for more bandwidth. 4G eliminated the use of circuit switching, and circuit switching is, for example, when a call is made, switches within the telephone created a continuous wire between the two phones. And 4G switched this to an all-IP network, which is a communication network that uses internet protocol addresses to send and receive messages between one or more computers. 4G also treated voice calls like any other type of streaming audio media using packet switching, which is wireless. It also provided improved mobile web access, IP telephony, which is just the communication between technologies that use internet protocol packets. It also had gaming services, high-definition mobile TV, and 3D television. And the image I have is of the iPhone 8. So this image I thought was interesting because it shows the transition from 1G to 5G and all of the, like an example technology of that timeline. And there's a question mark under 5G, which I think is interesting because when we get to the pros and cons, I think most of them are focused on the pros and cons of the cellular side of the 5G network, as opposed to what it can be used for in other devices and other applications. This is also just another graphic, which is kind of a simpler breakdown of what was added in when each new generation happened. So the 5G pros. Using millimeter waves will allow for increased speeds and almost zero latency, which means no time delay. Also, like I said before, robots and other devices like cars can benefit from 5G connectivity. 5G will be able to boost capacity by 4 times over current systems by leveraging wider bandwidths and advanced antenna technologies. And also, 5G will accept small, inexpensive, low power devices, so it will connect a lot of smaller objects and different kinds of sensors to the internet. So the cons of 5G is that the low band of 5G is slow, comparable to the speed of 4G and LTE because it uses frequencies below 1 gigahertz. The high band uses millimeter waves, so they travel shorter distances. Also, millimeter waves do not travel well through windows, walls, or bad weather. Cellular providers will also have to use many smaller, lower power base stations, generally outputting 2 to 10 watts in order to offer the faster speeds. So overall, I think 5G is probably going to be more applicable to other devices and other applications aside from cellular, which I don't think is a bad thing. I just think right now a lot of people think the 5G is the new cellular network, which obviously is not going to be, because this low band is going to be slow, which a lot of cellular networks will use. It's not going to be made, or you won't see much of a difference compared to the 4G that we have now. I think where the real difference is going to come in is with like connectivity between cars and robots, like I said before, and other devices and sensors and so I think that the pros and cons are generally geared towards cellular like issues and stuff, whereas it can have a lot of pros for other applications. So yeah, thank you.